Hi, I'm Gopinath. I'm doing some basic research on desalination of seawater, reverse osmosis water, and how to do zero liquid discharge. I'm, I'm making this into three categories, three different categories. The first one is removal of salt from the seawater and other concentrated brines. The second one is removal of boron, and the third one is zero liquid discharge for chemical and other industries. Now water shortage is there all over the world. The demand is increasing year after year, and um, the seawater will be the only source, perennial source, to meet all the requirement of water for different purposes, mainly for drinking purpose, for industries, as well as for agriculture purpose. But the seawater is having a little problem in the sense it is having about 3% salt. How to remove it? Many methods have been done. One is distillation, and the other one is reverse osmosis. But both the process have got limitations in the sense it takes about 30% to 40% water, and remaining 70% water it is discharging to the sea and polluting the sea in the sense the concentrated brine going to the sea um, eliminates all the fish and other marine food and spoils the ecosystem. How to avoid it? So for this purpose we have developed a repellent system. You see, when seawater is cooled, you get ice, but the ice contains nearly 4% or even more than 2% salt. So that is not fit for human consumption. So to avoid it, we add a small dose of repellents. The property of the repellent is that it will not allow the salt and ions, inorganic ions, to come nearer the water molecule. Then how to do it? Now, for experimental purpose, we have taken a small quantity of seawater. To this, you add repellents and then filter it to remove all the suspended impurities, deaerate it to remove all the air and other gases, and to the clear liquid, you cool it. And when you cool it to -4 degrees centigrade, it becomes ice, frozen ice. And this ice is because it is suspended in the seawater, it is having a coating of salt. So to remove it, we centrifuge it, and by centrifuging, all the adhering water is removed, and you get pure crystal clear ice. This on melting, you get potable water. This is the basic process what we have done for seawater. The same process we can do for other type of water also, because in Gulf the seawater contains huge, fairly higher amount of salt, ranging up to 6% salt content. So to remove it, we prepared a artificial seawater, and we subjected the same treatment for desalting the seawater, and a little variation in the process conditions were there, and with these modifications we were able to get desalted water, and The yield, the main thing is the yield is much higher than what we get. Now this is with respect to um, normal seawater. This process applies to normal seawater, uh, RO water, that is the retentatives of RO water, um, nano water, and produced water from refineries, mining water, and thermal water from the thermal industries, like that. Because all these salts, all this water contain higher salt quantity. So all these salts can be removed by using the repellents. We have successfully done, and number of experiments have been got it approved. Now, in countries, in European countries, particularly Portugal, Spain, and other places, as well as in parts of US and Australia, they have borated water. That means boron is really required to some extent for drinking purpose, but beyond certain limits, it spoils the human reproductive system, as well as for the soils, soil fertility is affected. So beyond certain percentage, it cannot be. It is not advisable to use it for cultivation. So for this purpose, we prepared a special ion-specific repellent, and this repellent, when it is added to the borated water, cool it to freezing temperature, and centrifuge it, you get a fairly good quality ice. And if you can do second time also, second stage of desalting, and by that you get a fairly good quality of desalted potable water. So this is another good achievement which we have done it, because so far there is very little success in removing boron. They are doing by reverse osmosis, by ion exchange process, and so many other systems are there. But the problem is they are all a little slower and not very much dependable. Whereas the repellent process does a good job with the same machinery and process. The chemical industries, particularly, um, um, use lot of quantities of a lot more of water. Same thing is mm, petrochemical industries and mining industries, pharma industries, electrochemical industries. They do lot of chemicals, and they discharge fairly good quantity of water, and the pollution becomes a big problem for such type of water. So with the implementation of pollution control, and they're finding it difficult, and so government has in various countries they have stipulated strict stringent regulations. So they do not have other option than boiling the water and evaporating the whole system of water. That means it requires lot of energy. It is ranging about 100 to 300 kilowatt hours per cubic meter of water to evaporate. So to avoid such an expensive process, we developed a cold process, cold zero liquid discharge process. This process is a little modification of the repellent process, wherein we add ion-specific repellents to remove the salt from the system, cool it to freezing temperatures, and centrifuge it to get a good quality of water. In fact, we have done an experiment from the wastewater we got from the Gujarat chemical industry, and which had a TDS of about 40,000 ppm. And this on desalting, in the first stage itself, it came down to about 850 ppm. And after doing the successive desalting, it got reduced to about 350 ppm in the third stage. And the water that we had, we got a very pure see-through water from brownish yellow water. We got it almost clear water. And if there is a need, it can be further for two more stages. We desalted when we got highly concentrated concentrated salt, as well as more quantity of desalted water. The salt on concentrated raffinate or the retained water, when it is put it into solar evaporation, it gave a good yield of salt. The main advantage of this process, as cold as zero liquid discharge process, is that you get a more quantity of water. You get fairly almost 90% of water you can achieve, and you get concentrated salt. That means there's a chance to get iodine, bromine, bromides, and if it's a large scale plant, there's a scope to get even lithium and other rare earths. So these are the different processes what we have done it, and all the processes have been fairly done it bench scale experiments, and that requires pilot plant study, and we are offering on the three process to clients who are interested to undertake further work on a license basis, because this process has been patented both in India, US, and PCT also. Those who are interested, please contact us. We will be giving full cooperation, and all the best. Thank you very much.